Chapter 6 is now going further than linear and quadratic. We're going into cubics and quartics and quintics and so forth. Okay, we're going to study those. Okay, so first we need to be able to classify or identify each of the terms that are involved in any polynomial. Okay, so I'm going to give this to you as an example. So let's say we have 3x to the 4th plus 9x cubed minus 4x squared plus 2x plus 4. Okay, and we're going to identify each of the different terms. Okay. What is the term called that has no x with it? The constant. Good. You already know that one. Okay, so that one's called the constant. The one with just an x is called linear. Good. Okay, we just got done studying all the x squared stuffs. Those were called quadratics. It's a 2. I crossed my z's, just so you know. Anybody know what the x cubed is called? Cubic. Very good. Yes. Okay, so that's a cubic term. What about x to the 4th? Close. Quartic. Quartic. Okay, and then anything above 4, they kind of stop giving them cool names and just saying 5th degree, 6th degree, 7th degree, 12th degree. Okay, then they just name it that way. Okay, you also have to be able to say how many terms each polynomial has. Okay, so something with one term involved is called a, anybody know what one, the word for one is?
No.
What?
No.
No, that's a different language. That's kind of close though. Mono, very good. Okay, so a monomial is something that has only one term involved. Hey guys, people who have a tablet open, will you please shut it? Because it looks like you're being distracted and I don't think there's any reason for you to be using those. Okay. Okay, what about two terms?
Binomial.
What?
Binomial.
Bi, very good. Binomial. Ooh, okay, what about three? Nice, now you guys got it. Trinomial. What about four? Four-nomial? No. Actually, that's pretty close. What? So this is where they get lazy and they just call it a ignore that. A four-term polynomial. Yeah, so they only go as high as 3 and then they get lazy and just say, oh, it's a 5-term polynomial. It's an 8-termed polynomial. Okay, so this is exactly what you're going to be doing first. You are going to start by classifying the polynomials. Okay, so for example, let's say you had 4x minus 6x plus 5. Okay, now before you can classify it, you have to simplify it, and then put it into its standard form. Okay, so which means you have to put it in order from the biggest exponent all the way back to the constant. Okay, so can I simplify this at all? Yes, I have two like terms, so I have two x's. How many x's do I have if I have 4 minus 6 x's? -2. So negative 2x plus 5 is my polynomial written in standard form. So if I classify this, I start with the biggest exponent. Which kind of term is that? The front one. Like, you're close. Okay, linear. It's not quadratic, it's linear. So it's a linear. And then I say, how many terms are there? Binomial. Good. Okay. That's what you'd classify that one as. Let's do one more. Let's say you have 3x cubed plus x squared minus 4x plus 2x cubed. Okay, first of all, can I simplify that?
5x cubed.
Good. I have 2x cubed terms. If I combine those, that makes 5x cubes. So then I have plus x squared minus 4x. Okay, so to classify this, my biggest exponent is a cubic. So I have a cubic trinomial. Good. One more? One more just for funsies. Okay, what about number 3? Is that one written in standard form? No. Okay, I have to have it in the correct order, so I would really say that this is negative 2x to the 5th plus 6. So what is this one?
5th degree.
Very good. A 5th degree binomial. Okay, so anything bigger than 4, you just call it that. 10th degree. Easy? Okay, we also need to make sure we know what all the functions look like. Okay, so eventually we're going to be able to identify all of them, but we're going to start out nice and slow. We all know what a linear function looks like, right? What do linear functions look like? What? A straight line. Straight, there are no curves in it, it is totally straight. And we know what a quadratic function looks like. A U. Anybody know the technical name for the U? Okay, it is technically called a parabola. Okay, so we're going to investigate cubics a little bit. Anybody know what a cubic function looks like? Like it is kind of like an S. Yeah. Anybody know what the name for this one is? Well, technically there is no name, but I have a name for it. What? My name is far more creative than that. I call it the John Travolta. Why? Oh. So I like to imagine, like, if you were going to become the function. Okay, so if I was going to become that S, I would have an arm up here, an arm down here. What does it kind of look like I'm doing? Yeah, like disco dancing. I would do a move, but I wouldn't want to hurt myself. Anybody ever seen the movie Saturday Night Fever? Well, someday. Hey, will you type in Saturday night? See if that catches it. Oh, close. Live. Saturday Night Fever. There it is. It's a movie from 1977, which is older than me, just so you know. I'm not that old. See? Do you see it? See, like he's totally a disco dancer. So it's a movie about disco dancing starring John Travolta. So that's why I call it the John Travolta. That's pretty cool, right? You guys will always remember that forever. Alright, so this is the very last piece of this section. What they're going to do is they are going to give you some data points and ask you to come up with a cubic model. Okay, so this is where the calculator comes into play. So grab your calculator.
Should we write those down?
I would. I mean, it's up to you. They're your notes. Okay, so we're going to, let's see if I can, there we go. What's that? Okay, so there's my points, and I got my, oops, calculator. Hold on. Wait for it. Where's Wabbit? There it is. There we go. Okay, everybody got your calculator. Okay, so we did this before with quadratics. Okay, the only difference is now we're going to do a cubic model on the calculator. So who remembers where do we go if we're going to input data into the calculator? That's an equation. Stat. Okay, so technically we are doing statistics. That's why we go to stat. Statistics is you take data, you're going to analyze it, you're coming up with an equation to fit it. So that's why we go to stat. So we're going to go to stat, we're going to go to edit. Okay, and since I have information in there previously, I'm going to go up and highlight my list 1 and hit clear, enter, so I can get rid of that previous data. Okay, once I've done that, what kind of values am I going to put into the list 1? The x's, okay? So all of the x values go into list 1. So I have -2, -1, you guys are going to be way faster than me. But maybe it's good to go slow. 0, 1, 2. Okay, and then my y values go on list 2, so I got -7, 0, 2, 3, 9. Okay, so once I have all of my data in the calculator, where do I go to have the calculator generate the equation for me? No, that's when you input an equation and you're looking at it. Close. Oh yeah. So you hit stat again, and we're going over to calculate. And which one are we going to choose? The cubic. We're coming up with a cubic regression model, which is just a fancy word for equation. I'll get there someday. There we go. It'll say it in the directions. It says come up with a cubic regression model. Okay, then we hit enter. You might need to hit enter and go down to calculate on your calculator depending on your operating system. Okay, so when it pops out the equation, that looks very similar to a polynomial that we just talked about with each of the terms. Okay, so my equation for this is going to be y is equal to 0.83. Let's just round to 2 decimal places. X cubed minus 0.21 x squared plus 0.67x. Oh, I'm going to lose my spot. There we go. Plus 1.83. Okay, and that's all you have to do for that. Everybody follow that? Did anybody get lost or need help with the calculator part? All right, perfect. All right, so then that is it.